distance and midpoint, the basics. So if you're given 2 points, x1, y1, and x2, y2, and again, the 1s and 2s, they're subscripts, they're just names, they're not important that they're 1 and 2. They could have been a and b or whatnot, or a name. The distance formula, the d, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So what happens here, if we have this grid, and we have this point here that's x1, y1, we have this other point up here that is x2, y2. What we have, if we drew a triangle here, a right triangle, then this distance here is y2 minus y1. This distance down here is x2 minus x1. And then this is my d. And if you use the Pythagorean Theorem, right, the two sides squared added together equals the d squared, and you take the square root, use the square root property. But again, we don't worry about plus or minus here because d is a distance between 2 points. So that's why we have d equals with no plus or minus there. Use the Pythagorean Theorem and then use the square root property. Then you don't worry about the plus or minus because, again, it's a distance between 2 points. So that's where the distance formula comes from, right? It's a really forgiving formula in the sense that you can start with x2 here and you could actually go y1 here. You really don't want to get in that habit or do that. But if you messed up and did that, it won't matter. Just subtract the two x's and square them. Subtract the two y's and square them. Because you're squaring them, the order you subtract them in doesn't matter because a positive 3 squared is the same thing as negative 3 squared. They're both 9. So, because they're in parentheses, negative 3 in parentheses squared. All right? So then, and you could even put the y's before the x's. It's what I call a forgiving formula. All right? So then the midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2 isn't a point. And what you're doing is, it's like you take 2 tests and you're getting your test average. You're just adding it up and dividing by 2 for the x, adding up and dividing by 2 for the y. That's all you're doing. Okay? So, literally the average of the x's and the average of the y's in it, each respective, like x, y, in the coordinate there, the x and y for the point. So let's jump right in here and try some of these. Let's go in here and say, let's determine the distance between the following pairs of points and the midpoint of the line segment joining each pair of points. So let's go in here and let's say this is going to be x1, y1, x2, y2. And the first thing I'm going to do is find my distance. And anytime I have these formulas, what am I going to do every time? Write down my formula, but I'm going to write it the same way I had it. x2 minus x1 squared plus y2 minus y1. And you could put the y's before the x's. It doesn't matter. You just need to subtract the x's and square them in parentheses. And then subtract the y's, square them in parentheses. And then add them together, take the square root. Okay. So d equals the square root of x2, in this case is 3, minus 2 squared plus, and I did that wrong, I did y's, so let me go back and fix that. Y'all are screaming at the computer, I can hear you. x2 is 1, minus 2 is x1 squared, and that even looks funny, so let me fix that. I'm just making all kind of mistakes right now. All right. And then plus, and then here, y2 is going to be 3, and then minus a negative 6 is plus 6. Hopefully I got through that one unscathed. All right. So this is going to be d equals the square root of, this is negative 1 squared plus 9 squared. You don't have to have the 9 in parentheses, but if you want to, you can. But because it's positive, it doesn't have to be. However, you cannot do this. There's many things wrong with this. One of them is this. The other that needs to go all the way. Okay? No. Negative 1 squared, the only way to square the negative and the 1 is if it's in parentheses. If you don't write parentheses, you're wrong. If I don't write parentheses, I'm wrong. If your teacher doesn't write parentheses, they're wrong. If the Pope doesn't write parentheses, the Pope's wrong. The president's wrong. The whoever, I don't care. If they don't write parentheses, they're wrong. It's got to be there, okay? Parentheses must be there. So then this is going to be, and I could just be going equals out beside it, but the square root of negative 1 in parentheses squared is negative 1 times negative 1 is 1 plus 81. So this is d equals the square root of 82. D equals the square root of 82. 82 is 2 times 41. 41 doesn't have a perfect square in it, so you can't simplify that anymore as far as the radical goes. Now, if you wanted to get a decimal approximation, then, however you punch that in your calculator, you could punch that in and get you a decimal approximation. Okay? So the square root for me, for my class, I love exact answers. Square root of 82. Now, you may have already done this, but before we punch this in a calculator and see what it is and get a decimal approximation, because I want to do that just in case. Some books say give it to 2 decimal places, some 3, some teachers say give me 4, some say give me everything your calculator shows you, all that kind of stuff. So we'll just write down some numbers here in just a minute and then approximate this. But in our mind, let's logically think about this. What do we know the square root of real close to 82? How about 81? What's the square root of 81? 9. The square root of 100 is 10. So anything between 81 and 100 that we take the square root of ought to be 9 point something. So I only go through that to say this. If you punch that in your calculator and you get 5.6, don't write that down. Don't write that junk down. All right? So if you, look, it's like when I ask on my 20-foot ladder is 4 feet from the base of the wall. How high up the wall does the ladder reach? 25 feet. It's a 20-foot ladder. It can't reach higher than 20 feet. If this is 81, the square root of 81 is 9, and this is a square root of 82, it's got to be a little bit more than 9. Right? Make sure your answer, don't just blindly write something down because the calculator told you. You punched it in wrong. If you got something like 5.6, you punched it in wrong. Okay? So this, if you plug it in and try to find it, this is approximately 9.055. And it goes 3, 8, 5, 1, 3, 8, 1, 3, 7, 4, 1, 7 on the calculator I'm using. Okay? But 9.05, 2 decimal places, 9.06. 3 decimal places, 9.005, 4, 9.055 for 3, 9.0554 for 4 decimal places because of 3, 8. All right, so there's a decimal approximation. I would love square root of 82, but decimals, that way you have it, that kind of thing. Because real world stuff, if you're working somewhere and you're making something that needs to be, square root of 82 centimeters long, it's 9.06 centimeters long or whatnot. It's not going to be square root of 82. You're going to have to know what it is. And then you're going to have to know from your situation and what you're doing on your job, do I have to round this to the nearest hundredth, tenth, thousandth? Is the nearest whole number okay? Probably not. That kind of thing. Now, if it's money, obviously we're going to round it to 2 decimal places because you don't pay somebody 2.5 cents for something. Okay? So then, square root of 82. So now let's go to the midpoint. Okay? Let's go to the midpoint. All right, the midpoint is going to be x1 plus x2 over 2 and y1 plus y2 over 2. So x1 is 2 plus 1 over 2. And then this is going to be negative 6 plus 3 over 2. And they're still in points. They're still points. So this is going to be 3 over 2, comma, negative 3 over 2. And you really can't do anything else with that. Those don't simplify. You could, if you want to say, well, this 1/2. The only way these get really crazier is if your points are fractions or something like that already, or decimals or something, or radicals, and it may make this a lot worse. But either it's going to be an even number over 2, which simplifies, or an odd that doesn't. If you're talking about integers up there, but they're not always integers. So put in here 3/2, negative 3/2, and there's your midpoint. Okay, 3/2, comma, negative 3/2. All right. So let's look at another one. Distance and midpoint. Distance and midpoint. So here, I'm going to call this x1, y1, x2, y2. And the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And then I'm going to extend that out because I want my radical to go over everything. That's a very important detail. Make sure your radical goes over everything it should and not anything it shouldn't. It sounds obvious, but I have people all the time do this. Square root of 13 plus 41 minus 63. And they want the whole thing under the radical, but they do that. That's garbage. Make sure it goes over everything it should and not over anything it shouldn't. So d equals the square root of, and this is going to be x2 is negative 1 minus 3 squared plus 1 minus a negative 5 is plus 5 squared. So this is going to end up being d equals the square root of negative 4 squared plus 6 squared. And again, the negative number must go in parentheses if you're raising it to a power. Must. There is no other way here. It is not optional. The 6, you can put the parentheses there or not. It doesn't matter. It's the same thing. D equals, because you're raising the sign and the number to the power here. So if you square negative 4 times negative 4 is what? 16. We're not ready for the square root yet. Got to simplify inside there. This is like this in parentheses. You got to do the whole thing. Okay? So, it's a little too long there. All right, but notice, do you have any doubt what's under my radical? No. Plus what? 6 squared is 36. Again, don't do this. Right? Because that needs to go all the way out there. Okay? What is 16 plus 36? Square root of 52. So is 52 a perfect square? No. But let's see. 4 times 13 is 52. So let's break that up. Why did I pick 4 times 13? Because the square root of 4 is what? 2 square roots of 13, right? And that can't go any further. So 2 square roots of 13. But even going back to 52, if I were to get a decimal approximation, 49 at the square root of that's what? 7. So 52, if I take the square root, is going to be a little bit bigger than 7. So if you plug in the square root of 52 or 2 square roots of 13 and you knew it was 52 to start with, and you get 1.6, uh-oh. Don't just write it down. Don't blindly write something down because you got it on your calculator, right? The whole point in education, the whole point in math, the whole point in anything that when you're going to school and learning and when you're doing a job or you're doing something at home is to think about it. Use your noggin, okay? Use that brain of yours. It was given to you for a reason. Use it, okay? So here, make sure your answer at least makes sense. If you get 7 point something when you take the square root of 52, it at least has a chance. If it's not 7 point something, it has no chance. None whatsoever. All right? So we're going to take this. Let me clear my calculator out here. 52 and take the square root of it is going to be 7.211. And my next one is 1. And then 0.2550927979. So it goes on and on and on and on forever there. But 7.211 to 3 decimal places. 7.21 to 2, however many it says. All right? So then we come in here and say, okay, what about my midpoint? My midpoint is going to be x1 plus x2 over 2, comma, y1. And really, the books that I use, they do something like this. They call it xm and ym, and they say xm equals x1 plus x2 over 2. Look, I just put the whole thing in here. You're taking the average of the x's for the x, the average of the y's for the y. So this is going to be 3 plus a negative 1 is minus 1. Look, if you have 3 plus a negative 1, why on earth would you leave 2 signs there? And look, I will never ask my students. In fact, I almost require my students to get it down to 1 sign. It's 2 signs is more confusing than 1 sign. 2 of anything is more confusing than 1 of something. So why on earth would you want minus a negative or minus a positive or plus a negative or whatever? No. So you know that 3 plus negative 1 is really 3 minus 1, so let's just simplify it to that. So even if you write 3 plus negative 1, write it down again, 3 minus 1. Okay? So over 2 and then comma, and then over here we have negative 5 plus 1, right? Plus means don't change the sign, over 2. So this is going to be 2 over 2, comma, negative 4 over 2. And both of these are even numbers. 2 over 2 becomes what? 1. Negative 4 over 2 becomes negative 2. And there is your midpoint, the point 1, negative 2. So we got two integers there. I started to say whole numbers, but negative 2 is not technically a whole number. It's an integer. Whole numbers are 0, 1, 2, 3, 4, 5. They're not negative. So integers are positive and negative whole numbers by definition. So 1, negative 2 is your midpoint. 2 square roots of 13 is the exact simplified answer for the distance, but it's about 7.211. Which, again, application-wise in the real world, if you're doing something and you get the square root of 52, you probably need to know it's 7.211, okay? For my little, rinky-dink math class, I say, hey, give me the exact answer. But you need to know what it is. You need to be able to reason it out, and don't tell me it's 1.6 something. That's not right. 7.211, right? So then here, distance -2 to 8, or -2, 8, and -6, 0. So this is going to be x1, y1, and x2, y2. And my distance formula is the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses and squared as well, all under the radical. D equals is not under the radical. So D equals square root of x2 is -6 minus a -2 is +2. Isn't that right? -6 minus a -2 is +2. Yep, squared. Plus, and then we get, what do we get next? We get 0 minus 8 squared. Is that right? And then I'm going to extend my radical out there, right? So what I'm saying is, look right here. This didn't go out far enough. So I'm going to extend it out further there, okay, to make sure that everything is under the radical it should be. There's no ambiguity whatsoever. Nobody has any doubt as to what's under the radical and what's not. Square root of -6 plus 2 is -4, must be in parentheses, plus 0 minus 8, -8, non-negotiable, must be in parentheses. And again, my radical wasn't long enough, so I extended it out to make sure that there was no doubt there. So this is going to then be D equals the square root of 16 plus 64, which is the square root of what? 80. And that's just less than 81, right? So this is going to be just under 9. So you better get 8 point something when you do the approximation. But for the exact answer, this is going to be 16 times 5. 16 is the biggest perfect square that goes into that. So the square root of 16 is 4, and then square roots of 5. So 4 square roots of 5 is going to be my exact answer. And then when my approximation comes in, it better be 8 point. I'm going to go ahead and guess 9. I haven't punched it in yet, but it's going to be 8.9 something, I imagine. All right. So let's just punch it in here and see. Let's take in here the 80 and take the square root of it. And we get 8.944. I just turned my calculator off in the middle of reading that. All right. 8.944 and then 2719099999159. It keeps going. So 8.944 rounded to 3 decimal places, 8.94 to 2, that kind of thing. Again, in the real world, if you were working something, and I've seen this happen, I was at a vehicle. Actually, I was across the main road from a vehicle production plant, and it was a institution of higher learning, a university, had put a center for the advanced vehicular studies there. And they were making bolts that went into the frame of the vehicles they were creating across the street, and they were testing those things. And when they made the bolts, they talked about they had to be within 1,000th of a, I don't remember if it was a centimeter or inch or something. So then they didn't take the square root of 80. They did 8.944 centimeters or inches or whatever it was. Okay? And as long as it was within that acceptable give or take, it fit the vehicle frame, and it was safe in that sense of not coming out or not coming loose or being too long or whatnot or too short and not holding. So there's an application in the real world right there of, okay, here it is. We got to round it, that kind of thing. So now let's take this and go with the midpoint. Okay? So we have the midpoint's going to be x1 plus x2 over 2, and then y1 plus y2 over 2. So this is going to be x1 is -2. Plus a -6 stays -6, right? You don't change the sign. That's what a plus means in a formula. Don't change the sign. And then we get 8 plus 0 over 2. So we end up with -8 over 2, comma 8 over 2, and 8 over 2 becomes 4, so this is -4, and this one becomes 4, and there is your midpoint is -4, comma 4. -4, comma 4. So hopefully this helps you with distance, the distance formula, midpoint, the midpoint formula, or a variation of it may look a little different in your book, but it's just finding the average x and put it first, the average y and put it second. All right, so good luck with this.